All right, welcome guys back. So I'm embarking on a couple of new journeys here, a couple of new experiments. I'm going to be fixing this guy. I think I showed you guys I got a new display for it. But I'm also going to be working on the RD3DP Newman motor. And so like I do with all collabs, or if I copy something from somebody or they give me the files or I purchase them, I really enjoy supporting other YouTube creators, especially guys or gals that are in this space. But like I did with the solenoid motor, I always print out a smaller version just to see how things are going to work, how things are going to fit together. And so with the large Newman motor that Redesigned 3DP put together, I printed out one that was 40% smaller. And I printed out the different files. This is the actual core, or the actual rotor that sits in there like that. Where was I going with this? Oh, so yeah, so I printed out smaller so I could see how things fit together. Fortunately, this guy's designs are really well built. Everything fit together perfectly. These are the side pieces. These are the, I forget what he's calling them, but they hold the outer portion together. This is the top coil, the centerpiece, which is really well designed, and again the rotor goes in there, and this is the bottom coil. And I'm assuming these pieces, and they fit beautifully too, are for helping you to wind the coil. So you put one there, and then you put one on this side, and then you put it on a shaft and you wind the coil. And then take these apart once the coil is fixed in place, probably with some sort of glue. And then that will sit directly on there like that. Yeah, this will sit directly on there like that. Don't have enough room. Anyway, yeah, let me see. Let me get these guys together. That'll sit like that. This guy will sit on here like this. These guys then go on the side and they capture it like that. I don't know if I can do it. And then these guys go right here, and so forth and so on. Anyway, yeah, so I always print out a smaller version just to see how things are. You know, see how the printing goes, if I need any tolerance fixes. And I print each one of these pieces at exactly 40% smaller. And they fit together really, really well. Surprisingly well. Well, I guess not if you know what you're doing with CAD, unlike me. And I even printed out his logo, which was quite tricky to do. I had to print this out on a raft because for some reason it just wouldn't print normally. I didn't want to use a brim, so I just did it with a raft with a nice separation, and I was able to pop it right off. Anyway, yeah, so I'm going to do that, but the first thing I'm going to do is I'm going to work on this other RD3DP design. And so the first thing I need to do with this guy is wind the coils. I'm going to use 28 gauge wire, and there's a space in there. I don't know if he has iron core in there like a screw, but I'll use that obviously to, and I don't know if it goes like that or if it goes like this. I'll have to take a look. I don't know if this little bump here goes on the inside. I think it does, but maybe not. Maybe it goes on the outside. I think I'm going to have to check the spacing between here. So I think, yeah, it does go on the outside, because if I tried to do it on the inside, it wouldn't fit in there. So yeah, I'm not going to concern myself with winding these super pretty. I just want to get them wound, and there's 6 of them I have to do. And I think he put on, when I bought this and downloaded it, I think he put the directions on how many turns and so forth and so on. So this printed out really nice too. Here's the rotor that actually sits on here, like so. I have to first find if I have a bearing that's going to fit in there, because I made this design 40% larger than the actual design. And the actual design size called for a skateboard bearing, and 22 millimeters. I believe the 40% increase bumped it up to 2 sizes larger on the bearing, and so it should fit perfectly in here. The bearing would have a 10 millimeter ID and I think a 30 millimeter OD, and I believe I have some of those. So let me get that going, and we'll see what we will see. I've been putting this off for quite a while though, so I may just try to fix this really quick and wind the bearings at the same time. I mean, well, wind the coils at the same time. Something like that. All right, stay tuned. All right, so I'm epoxying these guys together. These are the coils for the Zero Force 3DP or RD 3DP motor. And here is my coil winder, which has a counter on it. Click it to 0. There's 1, 2, 3, so forth and so on. I have to figure out how to rig up a jig that'll screw onto this and hold these on the very end here, because obviously I can't go all the way down here. I thought about winding it off of the bobbin and then sliding it on after the fact, and I thought, no, there's got to be a way. I just got to put my head to it. Actually, let me put my 3D printer to it. It's got to be a way I can do this, which I'm not too worried about that. There was a flaw, though, in this coil winder, wherein this is barely holding on to the bar here because it's too close. If I try to push it all the way in the way it's supposed to be, this hits this bar here. That's why I've never used this, and I've only ever wound this without the counter. But I think it's important to use the counter for this particular, for these coils, because I do believe he said, I don't know, 300 turns, or I'm going to have to go back online and see. There's a set amount of turns, 28 gauge wire. And I have 28 gauge wire. This is minute epoxy. I don't really know what that means. Most of the epoxy I get is 5-hour epoxy. There's 5-minute epoxy. This is called minute epoxy. So I'm not really sure what that means. It means that it instantly set, or actually, I'm sorry, it's called minute weld. Minute weld. Freaking camera doesn't focus. Yeah. So when these things dry, well, let me go design or think about some kind of jig to hold them on the end of this guy. And I'll bring you guys back. Stay tuned. So it turns out it wasn't as hard as I thought it was. And old prints that I don't use turn out to come to the rescue. So these guys that I made for my maglev, I made a bunch of separate ones, and it just so happens that they fit perfectly on the end of this with a nice tight fit that if I turn it, it screws itself in. And then I just used my soldering iron to heat set one of these counter set screw things, whatever they're called. I forgot what they're called. Countersink or counter set or something. Anyway, this will go through there, get locked down with a nut. I'll lock it down with this bigger nut. I'll also put the smaller nut on there, put that on there, jam the smaller nut up against that guy there, screw the whole thing on the end of that, and Bob's your uncle. I love it when I figure out how to do something and I don't have to make anything new. All the stuff I need is right there in front of me. I just have to kind of think outside the box or think outside my head. Yeah, and these counter set or countersink, whatever they're called, brass tips for the iron worked out perfectly. That thing sunk in beautifully. And it just so happened it was the right size hole on the end there. I love it when it comes together. Now I just got to wait for the minute weld epoxy to, what are those stupid things called? It doesn't say, oh, it does say, but I gotta, these are called, it's just made by Hitachi. I don't know. Anyway, you know what they are. You know what they are. I know what they are. You know that I know that you know that I know that you know what they are. Anyway, stay tuned. And that's how it works. Just like that. You know, too bad I couldn't figure out how to set up multiple ones on a longer screw. No, that's crazy. But that'll work just fine because I don't have to make it super tight. And it's all locked down. Oh, that stupid dog. So we have a Morkie, a dog, who's a great dog. He's a great little dog. He's part Yorkshire Terrier and part Yorkie, right? They're called Morkies. And so we're babysitting another one. It's a white one. We were supposed to have it for 45 days. This lady was moving to Australia, and apparently it takes an act of Congress to get a dog shipped to Australia. And it's been 6 months. And we've grown quite attached, but the dog is a barker anyway. I think that looks freaking great. So now I just got to let the epoxy set up, and it turns out that this is pulling it together. I wish I had more of these. I could set up the rest of these. Maybe I could set up a few of them, though, just to make sure that they are nice and tight to dry from the epoxy. Anyway, stay tuned. Yeah, so it turns out I've got a few of these little brass jam nuts. I think I got them at Ace Hardware. Yeah, I think I bought a bunch of them, but I only have a couple more. So I think what I'll do is I will... yeah, I'll just wait for the stuff to dry, and I'll use different nuts than the jam nuts, but I'm going to put it all through there. I'm going to put the other screws in there, tighten it up, and let it dry overnight. So see you back here at mañana. Forget going to Ace Hardware. I don't need these big fancy nuts. They're only temporary anyway. I found some more. I forgot I bought a whole bunch of small brass nuts, and silver nuts and galvanized nuts, and I got nuts everywhere. So now I'm still gonna leave these like this overnight though and wait for them to dry. I want them to dry really good, even though it's a minute weld epoxy. So I guess I will see you tomorrow. All right, so I started winding these coils and I rigged up because doing it by the hand crank just wasn't cutting it, especially with this super thin wire. This is 28 gauge. I'm going to put 500 turns on each bobbin. What I forgot to do with this one was I forgot to get the glue off of the inner part. So there's a really weird like bump there with the wire. So I may do this one over. Now I know in his video, his wire comes all the way out to the edge, but I think 500 turns is probably going to be enough. And if I do it like this, I can get it done pretty quickly, because if you guys don't know, I hate winding coils. Even though I do it a lot, I have a lot of coils. A lot of these were around for me, like that's a Sky coil, that's a Sky coil, but the rest of them, and that one is, but the rest of them are mine, except for that one way back there. That's a Sky coil too. But these were with much bigger wire, so it's easier to wind by hand. This way, I have it, my counter here, the drill there, the only one that fits that arbor or that rod. And then I have my wire over here, which I need to move. And yeah, I'm using a glove. My hand's in the glove when I'm doing it to just go back and forth. Anyway, stay tuned. So the second one didn't come out too bad. And like Jimmy DiResta always says, you always go to school on the first few. Well, he says you go to school on the first one, but he's Jimmy. I go to school on the first several. And I think I'm going to have to order magnets, because I looked around and I don't think I have any inch long by 5/8 to fit in this rotor. The rotor, the magnets would have to fit in there. And that's about 1 1/8 by 5/8. I don't think I have anything even close to that. So I'll get the coils wound, but then I'll have to move on to winding the coils on these guys here. And this will be done nicely because it's much larger wire. I think he used like 20 gauge on that. Anyway, stay tuned. So you know it's so dumb, and I think Magnus Attractus told me about this a while ago, and I took his word. I went out and I got a small motor with a foot pedal. It's over here somewhere. And it would take me all of maybe an hour to set that up. And with the foot pedal, I can control it better and, you know, really get these wound nicely instead of farting around with this janky setup. But I'm impatient and I'm lazy and I don't want to build another machine. But I really should invest in doing that, because I do wind a lot of coils. So maybe I'll take a look at that really quick and we'll see. Stay tuned. All right, so I've got to order the magnets, like I said, for that Zero Force motor from Redesign 3DP. But I'm going to start on these guys here. And I'm so stupid. So I thought that when I got the files that this just went on there like that and the other one on the other side. And then I just wound the coil like that, just being careful not to spill over. But I'm thinking, no, that doesn't make any sense. And then I started thinking, and then I realized, duh, he named these coils A and B for a reason. They fit together like that. So I got to print out 2 more of these, or 1 more each of A and B. Then these go on like that, and you can wind it. So, yeah, I was not thinking it through, and I was just about to print out a lip for this that would fit over that. And again, this is the 40% reduced in size version, because I always do a test first just to play around, and then I'll do the real deal later on. But yeah, I should have known, as well as he designs things and as well as they fit together. I mean, even when I reduced it, all the dimensions still work beautifully. I mean, that fits together beautifully. Little crazy glue, if I even need any. But yeah, I'll put some glue on there. I have to adjust my settings, because the seam I'm getting is really big. That's a crazy size seam, but I can file that off. Anyway, can't believe I didn't realize that before. All right, so let me get this thing hooked up. I'm going to use the same system I used on the other one, but without the drill. I'm going to hand crank that so I can. I think he calls for 500 turns on the normal size. So if I do a 40% reduction even in the turns, that'll be like, I don't know, 200 and something winds. Yeah, something like that. I'll figure it out. So probably 200 or 300 winds instead of the 500. And I'll use a little bit higher gauge wire. Like he calls for 20 gauge on the normal size model. I'll probably go for 21 or 22 gauge on this particular model. Anyway, let me get going. Stay tuned. All right, so I'm not going to get any of the motors built that I wanted to get built this weekend, so I decided to break out an old favorite. So this is a massive rotor. Here's my hand. These are 10 bar magnets. I believe they're 3 inches by ½ inch by ½ inch. And it's a maglev of sorts. So it's being supported. So there's 2 opposing magnets. So, well, yeah, it's a little tight, but it's being supported by those 2 opposing magnets. And it's a beast. I can spin it, and it'll keep spinning forever because of the flywheel effect. So let me get a, I'm going to find a coil that's a bifilar coil and hook up my dual JL94 circuit to it. See what we can do, because I haven't run this in a while, and I've never used the new dual JL94 circuit on it, so stay tuned. Yeah, JL94 circuit, a lot of output. That bad boy is flying, and it's balancingly nice on the magnet. So this is one of my more recent coils that has the iron core in it, and it's really going good. I have a solid output on the light. Even in the video, it's kind of solid. I gotta be careful though, because I don't have this thing buttoned down, but it's looking good. Increasing in speed because the coil is starting to slide closer to it. Let me see how close I can get it to it. Oops. Yeah, I don't even really need to get it close. That thing is flying. I mean, really flying. That's the fastest I've ever seen it run. I don't have to worry about magnets flying off of that. I have that big brown skirt or shield around it. That is a great circuit, man. It's running so much back EMF, it's even still lighting up the neon bulbs, which are there to protect the two transistors. But yeah, that's the most output I've seen it do. Let me turn it off. That thing is flying. So I tried this coil, which I really like, but for some reason it doesn't work. It's not shorted. I checked it, but I don't know why it's not. Whoa, 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 whoa. Calm down there, buddy. Calm down there. Yeah, see, this thing will spin for like a half an hour. Let me get this off of here. Put it out here. You know what? I've got some what you call it on there, some reflective tape. I should measure it up and see when it's spinning, when it's at full force. I can't do this one-handed though. I should have put my camera in a tripod because now it's starting to spin down. All right, let's see what it's doing now anyway. 1,000 RPM. But that's saying that's not right. Anyway, yeah. Oh, it dropped down. No wonder. It fell off of the magnet. I gotta slide it back underneath there. So I have the repulsive magnet on a sliding thing. I've got to lock that into place. Yeah, this is a really cool motor. Well, I like it anyway, and it has a lot of magnets, but I can't figure out why this guy won't work on it. Like I said, it's not shorted. I checked it. It's a bifilar just like this guy. I don't understand why it's not working. Let me try it with just one of the coils and see what happens. Because I hooked it up to the dual JL94 and it didn't work. Nothing happened. I can't figure out why. Let me hook this guy back up, but this time I'll secure this to the platform. Stay tuned. Oh yeah, and really quick, there's no worry about the iron core, which is a temporary core. I can take it in or out. No worry about it flying that way because I have that end sealed. That's a solid piece there. So the core is right up against there, but there's no way it can come out. So let me get it spun up again. So 350. Takes a while because this thing is so massive. It takes a while for it to get up to speed. .600 RPM. 800 RPM. 900 RPM. This is a big ass rotor. 1,000 RPM. 1100. 1115. 1118. 1200. Still climbing. 1300. Still climbing. Thing's a monster. 1400 RPM. 1500 RPM. For such a big freaking heavy rotor. Will it get to 16? Yeah. 1600 RPM. I think it'll probably go to 2000 RPM because it's still climbing. 1700. Damn. That is a beast. I gotta make sure that this thing stays in place. Alright, let's see what we got here. 1900 RPM. It'll definitely go to 2000. God damn, 2000 RPM. I know that's not much when you compare it to like a maglev like that guy, but still for such a large rotor. 2100. It's still climbing. You can hear it. $2,200. Make sure everything is still nice and cool. Yep, all the circuits are cool. The coil is still cool. Everything is still running. Let me see how the transistors are. I mean the resistors. They're a little bit on the hot side. 2300 RPM and still climbing. That is a nice coil. It's a beautiful circuit is what it is. Alright guys, I think that's probably enough for this weekend. If you guys can figure out why this coil won't work, it's, like I said, it's not shorted. It's basically the same thing as this, except for it's in a different configuration and there's no iron core. 2384. 20 is still climbing. Will it get to 2400? Place your bets. 2400 RPM. That is a beast of a rotor for going so fast. Of course, the camera doesn't do it justice. If you were to see this in person, it's a blur. Whereas the camera shows it kind of flickering like that, it's an absolute blur. Let me turn it down. Yeah, the magnets that you can see up there, that silver, that's one, it looks like it's one solid magnet. Speaking of solid magnets, I've been watching Sky lately and he's messing around with his Searle engine again. I really want to build one of those, but you need special materials. Stuff I don't think I can get. Alright guys, thanks for watching.